Hello and welcome to Train Signal. You're watching Moving Virtual Machines with vMotion. In this lesson, I'll start off with why you need vMotion to begin with. I'll cover the requirements to use vMotion, and then I'll show you step by step how to vMotion virtual machines using vSphere 5. So with that, let's get started. VMware's vMotion is by far one of the most impressive and incredible features of VMware vSphere. In fact, it's the main feature that I think of whenever I want to demonstrate the power of server virtualization to someone. By demonstrating what vMotion can do, as long as they understand what's happening, you'll get an immediate wow or that wide-eyed look when they look at it and think, that's really amazing that a virtual machine can move from one physical server to another while it's running without any downtime to end users at just the push of a button. So that's what happens with vMotion. You've got a running virtual machine, moves from one host to another. The disk files actually stay where they are on shared storage. It's the virtual machine's memory and CPU processing that's actually moving from one server to another without any downtime to the end users. In fact, if you do a ping to that virtual machine over the network, while the vMotion is occurring, you may lose at most one, maybe two sometimes ping packets, but very rarely do you ever even lose those. Many times you might just see a high ping time and that's it. The virtual machine has transitioned from one physical server to another physical server. And there's many benefits to doing this. While you could use vMotion to randomly move a virtual machine from one host to another, most of the time there's some real-world need. And in fact, vMotion is used by many of the core vSphere features that you think about. For example, the Distributed Resource Scheduler, or DRS, actually balances the load, or really it ensures virtual machines get the resources they need, and when they don't, it uses vMotion to move virtual machines that need more resources to another server that can provide them. vMotion is also used by DPM, or Distributed Power Management, so that it can move running virtual machines and consolidate those virtual machines onto fewer servers before it powers down ESXi servers in order to save power resources when the utilization of a cluster is low. vMotion is also a very powerful feature to use whenever you need to install patches on an ESXi server or to perform physical server hardware maintenance. You can evacuate, that's what it's called, evacuate all the virtual machines from one ESXi server. Those will be automatically relocated on other ESXi servers when you put a ESXi host into maintenance mode. In fact, this is done with VMware's Update Manager, or VUM as they call it, whenever you perform an automated patching operation across multiple ESXi servers. No matter what your use case, vMotion is one of the most powerful features of vSphere because it keeps servers up and running and it keeps those applications up and running for the end users so that you can do what you need to do as a VMware administrator without causing downtime for the end users. Even though vMotion is one of the most well-known features of VMware vSphere, there are some very strict software and hardware requirements that you need to meet in order to be able to use it. First off, you need a specific vSphere license. That license could be either Essentials Plus, Standard, Enterprise, or Enterprise Plus. If you have the free vSphere Hypervisor or vSphere Essentials without the Plus, you won't be licensed to use vMotion on that vSphere server. Next, you need to make sure that you have shared storage between your ESXi servers, and your virtual machines need to be stored on that shared storage. That shared storage could be iSCSI, Fibre Channel, or NFS. It really doesn't matter, but the point is that your virtual machines need to be stored on that shared storage, and both of your ESXi servers need to be able to access that same data store. In other words, they both need to be able to see that virtual machine's virtual disk files, because when the virtual machine moves from one host to another, it's not going to be moving the virtual machine disk files. You don't do a vMotion and a storage vMotion at the same time. You just do one or the other. Next up, you need a VM kernel interface on both ESXi servers to be enabled with vMotion. It's a simple check mark, but it's a very critical check mark, or else vMotion is not going to work. And I'll be showing you how to configure all of this in just a minute. Next up, you should know that vMotion works with either standard switches or distributed virtual switches, but you need to have the same network name. In other words, that network name needs to be available on the source and destination ESXi server. And then finally, and one of the most important caveats here, is that you need to have CPU compatibility between the physical servers. or you need to have CPU family compatibility if you're using the enhanced vMotion compatibility feature of vSphere or EVC on your cluster. So what that means to you is that the CPUs on the source and destination ESXi servers either need to be the exact same CPU or they need to be from the same family and from the same manufacturer. In other words, they need to be all from, let's say, a similar family of Intel CPUs or a similar family of AMD CPUs. And you can find out more about this when you configure EVC. And I'll point that out in our configuration example in just a minute. But the point is, you can't just take two generic servers, let's say one Intel, one AMD, and expect to be able to do a vMotion from one to the other. That isn't going to work. So to very quickly summarize, you need a specific license for vMotion. You need to have shared storage where your virtual machines are located. Both servers need to be able to have access to it. You need to enable the VM kernel interface on both ESXi servers with vMotion. You need to have the same network name between the two ESXi servers, and then you need to have that CPU compatibility. And now we're ready for our exciting demonstration here. We're going to be vMotioning a virtual machine from one host to another. That is after we perform the necessary configurations to make this happen. And this is what it's going to look like. You're going to select that you want to migrate the virtual machine. That's what it's called. And then you have the option here of either doing a vMotion, which would be to change the host, or to do a storage vMotion, which I would talk about in another lesson where you would be changing the data store for that virtual machine's disk file. Note that you can't actually change both the host and the data store at the same time, but the virtual machine has to be powered off. And because the virtual machine is powered off, it really isn't a vMotion or a storage vMotion, either one. It's really just a copy of the virtual machine configuration file and disk file from one data store to another, and then it unregisters it from one host and re-registers it on another host. So at this point, let's go over to the vSphere client and get started with our vMotion configuration. Here I am in my vSphere client that I've connected to my vCenter server. And notice here I have two ESXi servers, ESX1 and 3. Notice that the manufacturer of these servers is Dell, and they're T610. So they're identical servers. And fortunately for us, they have the exact same CPU. So we don't have any problems with CPU compatibility. You can see here both of these servers have the Intel Xeon E5520 CPU. If I click on this other ESXi server, there, notice the exact same thing, E5520 CPU. It's the exact same server. So we've gotten past the CPU compatibility requirement. The other thing we should check for is the shared storage requirement. So notice the storage on this server. I've got access to the local disk and then two LUNs on a shared SAN, LUN1 and LUN2 on the iOmega SAN. So if I go over to the other server, very quickly I can see that it has access to the same local storage and then the same shared storage, iOmega SAN LUN1 and LUN2. Something else to notice here is that this ESXi server has a network named vMnetwork. That's the standard port group. If we go back to ESX server number 3, notice here we also have access to the same vMnetwork as well as some other port groups. But most importantly, it is the same vMnetwork, and we'll make sure that the virtual machine we're vMotioning has access or is actually using that VM network, because when it moves from one server to another, let's say from this server to the other server, if it was a member of one of these other port groups, and when it made the vMotion, it could end up on the other server and actually not have access to the network. That would be a very bad scenario for the end users, let's say, who are using the applications on that virtual machine. So that's why we need to make sure that the virtual machine has access or is using the same virtual machine network on each server. Something else we said we should verify is our license, whether or not our license is compatible with vMotion. Notice here my license, it says I'm using VMware vSphere 5 Enterprise Plus, and I can tell you so is the other server. So they both have Enterprise Plus. They both have no problems using the vMotion feature within that vSphere edition. And now we're ready to perform our vMotion, and for purposes of our demonstration, I've selected this virtual machine right here. It's the VMA Virtual Appliance, or the vSphere Management Assistant. If I click on that, let's take a look at this virtual machine before we perform the migration using vMotion. Notice that it's currently on host ESX1, so we're going to use vMotion to move it to host ESX3. Notice that it is currently powered on, so it may have some users, let's say there's some other vSphere admins out there using this VMA Virtual Appliance. Notice that it's currently using the virtual machine network, or that's the name of the port group, and that port group we found out was available on both of our ESXi servers, and notice that it's stored on iOmega SAN LUN1. And we found out also that both of our servers have access to that same shared storage. But what am I leaving out? We said that one of our requirements was that both of the ESXi servers need to have a VM kernel interface that's enabled to use vMotion. That's the last thing that we haven't checked yet. So let's go ahead and do that. Let's go to ESX server number 3. We'll go into the configuration tab and then down to networking. Underneath networking, I'll go into the properties here for our standard vSwitch. And let's take a look at the management network. Because this is a ESXi server, it doesn't have a service console interface. It's got this management network interface. So I'm going to click edit here. And notice this very important checkbox that says vMotion. Right now it is unchecked. It's not enabled. We're just going to check that check mark right there, and that's going to enable this server to use vMotion. I'll say OK there. And then notice over here where it says vMotion, it just changed from disabled to enabled. So we just enabled vMotion on this server. And I can tell you that I've already done the exact same thing on the other ESXi server number 1. And at this point, we've completed our configuration and we're ready to perform our vMotion. I'm just going to go to the Summary tab here, and then let's open up the task window so we can see the progress of the vMotion as it occurs. Let's go ahead and go to this virtual machine, the Vima Virtual Appliance, and I want to start up a ping window showing a continuous ping of the Vima Virtual Appliance. Let me go ahead and bring that up, and then I'll do ping -t for a continuous ping, vima.wiredbraincoffee.com. Alright, so we've got a continuous ping going there. We can see the average ping time here is between 3 and maybe at the most 8 milliseconds. So we're getting a really good ping time out of that server. I'm just going to move this off to the side, and in fact, let me resize the window a bit. So it's going to be totally off the side there. So when we perform our migration with vMotion, we can see that nothing happens to the pings. So I'm going to right-click on the Vima Virtual Appliance here, and let's go ahead and perform our migration. And notice we're going down and clicking on Migrate. We're not clicking on vMotion. The option here is to migrate the virtual machine. And this brings up the Migrate Virtual Machine wizard. Now we have two choices here because this virtual machine is powered on. We've got Change Host or Change Data Store. Change Host is the actual vMotion. That's going to move the virtual machine from one ESXi server to another. The Change Data Store would move the virtual machine's virtual disk file from one storage array to another, or from one LUN to another, but I'll be covering that in another lesson. So in our case, I'm just going to click Next here, and now we're being asked for the destination. Where do we want to migrate this virtual machine to? Well, in our case, we just have two ESXi servers, so we really only have two possibilities. The first one, of course, is the source. That's where the virtual machine is currently running on, and we already found out that that's ESXi server number 1. So we know that we want to migrate this virtual machine to ESXi server number 3. And once I click on the ESXi server, it does a quick compatibility evaluation down here to see if that ESXi server is going to be a compatible destination for the running virtual machine. I mean, we don't want to migrate the virtual machine to a host where it's not going to be able to work, essentially. Maybe it's going to crash, or maybe it's going to lose network connectivity. All these things would be very bad, and the purpose of this compatibility evaluation is to ensure that the virtual machine works 100% once it's migrated to the new ESXi server. So it checks things like CPU compatibility, whether or not vMotion is enabled on that host, whether or not that host has access to the shared data store, and whether or not that host has the same virtual machine network, and if that virtual machine port group has the same security policies that the source ESXi server had. So that compatibility check right there is very important, and in fact, if certain types of compatibility checks fail, it won't allow you to click Next here and continue on. Luckily, in our case, all of the compatibility checks succeeded, and validation, it says right here, was successful. So I can click Next, and now we can move on, and we're being asked about the vMotion priority. If you take the default of high priority, which is recommended, those are going to be favored over standard priority vMotions, and they're expected to perform better. In other words, let's say if you had multiple vMotions occurring all at the same time, or a large virtual infrastructure, you might want to have low priority or standard priority vMotions and high priority vMotions, because you can have, honestly, multiple vMotions occurring all at the same time on the same virtual infrastructure. So we'll just take the default here of high priority and click Next. And at this point, we're ready to complete our vMotion. I'm going to click Finish here. And then down here, we can see our vMotion is in progress. Let me bring up the ping for this virtual machine. So we can check the ping status. Notice there we had one request timeout. So we had one very quick ping that failed. And now the vMotion, or the migration of the virtual machine down here, we can see has completed. So overall, we had a 100% successful vMotion, with the exception of one ping, just one ping that was lost. And very likely, the end users who were using the applications on this virtual machine never knew any different. They never knew that that virtual machine was migrating while they were using it from one physical server to another, something that just, let's say, 10 years ago would never have been possible. So that's one of the most incredible features of VMware vSphere right there, is VMware's vMotion. Now, before I conclude this lesson, I did mention earlier that I would talk about enhanced vMotion compatibility, and that's something that's actually configured at the cluster level when you configure Distributed Resource Scheduler. We talk about Distributed Resource Scheduler in another lesson, but very quickly, let me touch on enhanced vMotion compatibility, because it is important if you don't have the exact same CPUs on your host if you're trying to migrate a virtual machine from one to the other. So I'm going to right-click here on my HADRS cluster. I'm going to go into Edit Settings, and then down here to VMware EVC. Currently, VMware EVC is disabled because, honestly, I don't need it. But I can here change the EVC mode, and I can enable EVC for AMD hosts, at which point I would have to select a specific processor family, a specific Opteron generation, in fact, is what it is. So the servers don't have to have the exact same CPU, but they have to be from the exact same CPU manufacturer and from the same Opteron family. And it's the same thing for Intel if you use EVC between Intel CPU families. So notice there's different families here, and all your servers don't have to have the exact same CPU, but they need to have the exact same CPU from the same CPU family. So if you select Core i7 here, notice that the CPUs need to be from this same list of Intel i7 family members, or Nehalem family members. So that's what EVC is, and it's used both with vMotion, but even to a greater degree with VMware's Distributed Resource Scheduler, which, like I said, we'll talk about in another lesson. So with that, let's go back to our slides. Before we end the lesson, there are a couple of new features in vSphere 5 that are related to vMotion, and these features were brought to my attention by Duncan Epping over at yellowbricks.com in a blog post he made that was actually an excerpt from his book. And in this blog post, he talks about these two new vSphere 5 vMotion enhancements. Now, I didn't see these personally in the vSphere 5 release notes, but it makes sense because these are rather technical, more advanced features that may not apply to the general population of vSphere users out there. But they are interesting features, and they apply to companies who have virtual machines that are, I would say, rather high performance. They're generating a lot of traffic, a lot of changes to the virtual machine disk file, a lot of changes to memory. Maybe they have, many virtual CPUs, and they're being hit or just slammed by the end users. So these higher performance virtual machines really can take advantage of these two new vMotion enhancements in vSphere 5. So the first one is the multi-NIC vMotion support. And multi-NIC vMotion support just means that the vMotion process that's actually transmitting the changes to that virtual machine from one ESXi host to another ESXi host can use more than one NIC in the server to do it. So instead of just using one NIC, as vMotion did prior to vSphere 5, it can now use up to 16 1 gig Ethernet NICs, or up to 4 10 gig Ethernet NICs. And Duncan points out that really to use full bandwidth of a 10 gig Ethernet interface in a ESXi host, you need to have the latest PCI Express buses in that server. You can't just throw a 10 gig Ethernet card in any old server and expect to get anywhere close to the full capacity or bandwidth that 10 gig Ethernet NIC can support. The second vMotion feature new in vSphere 5 is the stun during page send. And it's also called slow down during page send. And I talked about you trying to vMotion a high-performance virtual machine that has a lot of changes going on, what this feature can do is it can actually tell the vCPUs of that server to really slow down or go into a sleep state, but a sleep state that's not going to affect the application. So it knows the middle ground here between what will hurt the applications and what can just kind of slow down the processing of that system a little bit, to give vMotion a chance to really vMotion that high performance virtual machine over what could be, let's say, just one single 1 gig Ethernet interface. In other words, thanks to the stun during page send feature, you can now vMotion any sort of vSphere workload or any sort of vSphere virtual machine, regardless of how aggressive that virtual machine is. That's actually what Duncan says in the last sentence of the article. Like I said, these are more advanced features of vSphere 5, and they're for those enterprises out there who have those high performance and aggressive virtual machines. Still, I wanted to take a second to point out the 2 new vMotion enhancements new in vSphere 5. And that brings us to the summary for this lesson. We started off by talking about why you need vMotion to begin with. Honestly, it's one of the most impressive features of vSphere that gives you the power to move a running virtual machine from one host to another with zero downtime for the applications and end users using that virtual machine. It's used by a number of other features in the vSphere virtual infrastructure suite, such as the distributed resource scheduler, distributed power management, and even if you put a host into maintenance mode and the virtual machines are evacuated off of that host onto other hosts. Even though it's a very popular feature, it has a number of very strict requirements. You need to have a specific software license. You need to have CPU compatibility. You need to have shared storage where you keep your virtual machines. The virtual machines need to have access to the same virtual machine network port group on each of the ESXi servers, the source and the destination. And then each of the ESXi servers need to have their VM kernel interface enabled for vMotion in order for your vMotion to succeed. We ended the lesson by showing you step by step how to make sure that you've met those requirements, how to enable vMotion on the VM kernel interface, and then how to perform a vMotion using the virtual machine migration wizard. And we even verified that there was no downtime. Well, maybe just one ping was lost for the end users using the applications on that virtual machine. Thanks for watching this lesson covering moving virtual machines with vMotion.